welcome to our first unit in our study of trigonometry, which is really a branch of mathematics that looks at functions of angles. So that's really where we're going to start today, is we're going to start with our definition of an angle and some relevant terms in regards to angles. So this is what we already know. We know an angle is formed by two rays that are joined at a common endpoint, and that endpoint is called the vertex. So if I'm going to draw an angle, I'm going to start by drawing a point with a line extending in one direction. That's one of my two rays. And then I'm going to take a second ray that starts at the same point and extends in a different direction, and that common point is called my vertex. We know that we can measure an angle in degrees, and that measurement is a measurement of rotation. So the idea is that if I start at one ray and I calculate how far I rotate to get to the other ray, that is my measurement. Now we're going to call that angle with that letter, and that is the Greek letter theta. We use Latin letters like X, Y, and Z to be variables to represent the value of a number. We typically use Greek letters like theta, which are in this chart right here, to stand for the measurement of different angles. So I need you to know these letters, be able to recognize them by looking at them and by names. So this circle with a horizontal line through it, that's the Greek letter theta. This letter here, which almost looks like an A, I usually make my alphas like that. That's alpha. Beta, like a B, except it starts with a longer tail. Gamma is almost like making a skinny V. That's gamma. Phi is a circle with a nearly perpendicular line through it, PHI, but pronounced phi. And omega kind of looks like a fancy W. So those are the letters on your next quiz. You're going to need to be able to identify those letters by name and by symbol. All right, so moving on. These are also things we already know. We know that a right angle measures 90 degrees. So if I'm going to do a right angle, I've got my two rays, and I typically finish off the corner with a box to indicate that's a 90-degree angle. We know that an acute angle measures less than 90 degrees, so my acute angle might look like this, right? So maybe that's angle alpha. We know that an obtuse angle is more than 90 degrees, so if I'm going to do an obtuse angle, I've got to go beyond the vertical if I start horizontal and come here. So let's call that angle beta. And we know that a straight angle measures 180 degrees. So if I'm going to draw a straight angle, I have actually a line, which is two rays going opposite directions, and that would be 180 degrees. A circle measures, excuse me, 360 degrees. So the idea is that if I start in the middle and take a ray to one side, and then I rotate that until it meets itself again, that's a 360 degree angle, and following the tip of that ray as it travels around forms my circle. What's new to know? What's new to know is that when we draw an angle in standard position, we place it on the coordinate system. So our coordinate system, right, takes the plane of a piece of paper, for example, and divides it into fourths with two lines, the x and the y-axis. Right? Those fourths are called quadrants, and quadrant 1 is the section that is in the upper right-hand corner, and then if we rotate counterclockwise, quadrant 2 is in the upper left-hand corner, quadrant 3 in the lower left-hand corner, and quadrant 4 in the lower right-hand corner. So if we're going to draw an angle in standard position, we're going to take one side called the initial. Remember, initial means beginning side, and it's going to be on the x-axis pointing in the positive direction. So my initial side will always be a ray that starts at the origin and follows the x-axis to the right. The other side, called the terminal side, terminal means ending, will rotate out into the plane. So if I'm going to draw an angle in standard position with the terminal side in the second quadrant, then my initial side on the x-axis to the right, my terminal side going out into the second quadrant. So let's just estimate the size of that angle. So I'm going to take that and I'm going to use this arc to represent the size of that angle, and let's guess that that is, I don't know, it's a little more than 90 degrees, not quite halfway through quadrant 2 here, so let's say that's 140 degrees. Now, when we rotate counterclockwise, we give a positive measurement. If we rotate clockwise, we actually give a negative measurement. So if I come in here and I start at my initial side and I actually rotate clockwise, then my measurement for that angle is going to be negative. And I need these two angles to total 360, so that's going to be negative 220 degrees. So we have two angles, right? Two measurements of the same angle. One are positive 140 degrees, and the other are negative 220 degrees. The next thing we need to talk about are coterminal angles. And a coterminal angle, right? Terminal means end, co means together, are angles that both have the same initial and the same terminal side. An angle actually can have any number of coterminal angles, both positive or negative. So let's come back and let's look at this drawing. I have my angle, which is my 140 degree angle, so something like that. That's my 140 degree angle. If I take that 140 degrees, which I have rotated counterclockwise, and I actually extend that rotation another 360 degrees, I have another angle with the same initial and the same terminal side. How big is that angle? Well, if I take my 140 degrees and I add 360 degrees to it, I get, what would that be? 500 degrees. So a 140 degree angle and a 540 degree angle are coterminal. Could we find another angle? Well, if I come in here now and I go another circle around, then I'm taking my 140 degrees and I am adding 360 degrees twice. So I'm adding 360 degrees, which actually would get me to 500 plus another 360, which is 860 degrees. So in general, what is it we do to get positive coterminal angles, or coterminal angles that are at least bigger than what we started with? Right? What we do mathematically to determine positive coterminal angles is we take the measurement of our angle and we add any number of 360 degrees. So n in here is a positive integer. It could be 1, it could be 2, it could be 5, it could be 17. And it just says we're adding any number of 360s. Well, what about negative coterminal angles? Let's come back and look at our drawing again. And I'm actually going to clean this up a little bit, and let's go back to our 140 degree angle, which is about here, which had a negative measurement of negative 220. So here to here was negative 220. If I take that rotation and I extend it, so I pick up from where I ended and go around another 360 degrees, I went counterclockwise, so I have another negative 360 degrees. Then I am taking my negative 220 degrees I'm subtracting 360, and I end up with a negative 580 degrees. That negative 580 degrees is coterminal to my negative 220 degrees. If I wanted another one, then I would pick up where I left off, rotate another 360 degrees clockwise. So from my negative 220 degrees, I actually subtracted two 360s. So that would get me to negative 940 degrees. Another negative coterminal angle. So in general, what is it we do mathematically to determine negative coterminal angles? Well, we start with our theta and we subtract any number of 360 degrees. So in general, a formula we can use to find coterminal angles, so theta coterminal, is to start with the measurement of our angle, whether it's positive or negative, and to that either add or subtract any number of 360 degrees. And each angle we get from that result will be coterminal. Okay, the last thing we want to look at here is a reference angle. A reference angle is always an acute angle, so less than 90 degrees, between the terminal side of an angle and the x-axis. That could be either the positive or the negative side. A reference angle is always positive. So if I'm going to locate and label the reference angle for our angle, let's go back up here. I had my 140 degree angle, so that was 140 degrees. My reference angle is going to be the angle that is between the terminal side of my angle and the x-axis. There are two of them. I want the acute one, so I want this angle right here, and this is my reference angle, theta reference. But how big is that angle? We know that to go all the way around would be 180, but we are not going the 140, so if we subtract that, we end up with 40 degrees, and my reference angle is 40 degrees. So let's take that idea and let's expand it, and let's find the reference angle for these angles. So here I've got angle alpha, and alpha is 58 degrees. So from here to here is 58 degrees. What is its reference angle? Well, isn't this angle an acute angle between the terminal side and the x-axis? Yes. So our reference angle is 58 degrees. In general, if we have a quadrant 1 angle, the reference angle is our angle. Okay. Let's look at the next one. This is angle beta, which is 147 degrees. So that's 147 degrees. That should go to the origin. And the reference angle is going to be the acute angle between the terminal side and my x-axis. Well, that's going to be this angle right here. And in order to find that, I'm going to take 180 and I'm going to subtract 147. And when I do that, I get 33 degrees. So in general, what did I do? With the second quadrant angle, we take 180 and we subtract the measure of our angle. My third example, I have gamma, and gamma is 225 degrees. My reference angle is the acute angle between my terminal side and the x-axis. That would be this angle right here. That's my reference angle. And to find out how big that is, I'm going to take my 225 and I'm going to subtract 180. So that's going to give me 45 degrees. So in the third quadrant, we take our angle and we subtract 180 degrees from that. Finally, our fourth angle, and this is phi. So this is phi, and phi is 291 degrees. So we rotate all the way around. This is 291 degrees. My reference angle is the acute angle between my terminal side and the x-axis. That would be this angle right here. So that is my reference angle. And to find that measure, I'm going to start with my full circle, 360, and I'm going to subtract my rotation of 291. So I end up with 69 degrees. So here I took 360 degrees and subtracted my angle from that. Now, for you to find a reference angle, you can either memorize these 4 formulas for these situations, or you can just draw a picture and figure out what the angle would be from the picture. That's what I would do. So, putting things together, these are our objectives. We should be able to draw an angle in standard position, determine the quadrant in which the terminal angle lies, determine positive and negative coterminal angles for any angle, and determine the reference angle for any angle. Right? So, if I'm going to sketch an angle in standard position, 62 degrees is going to be about 2/3 of 90. That's 62 degrees. 137 degrees is going to be my 90 plus another 47. Right? So that's 137 degrees. Negative 243 degrees is going to start to the right and rotate counterclockwise 180 plus another 63 degrees. So that is negative 243 degrees. 565 degrees is going to be all the way around the circle, that's 360. Then if I subtract 360 here, I get 205. So I go another 205 degrees, and that is my 565 degree angle. So this first angle is in quadrant 1. My second angle is in quadrant 2. My third one is in quadrant 2. My fourth one landed in quadrant 3. Okay. Now, from here we want to be able to find the smallest possible positive and negative coterminal angles for each. And by smallest, I really just mean closest to 0. So the smallest absolute value. So let's start with 62. If we take 62, to get another positive angle, we would have to add 360 to that. We do that and we end up with 422. There is not another smaller positive angle. If we start with 62, to get to a negative angle, we would have to subtract 360. So if we subtract 360 from 62, we get negative 298. That's our negative angle. For our next angle, which is 137, 137 is less than 360. So it's as close to 0 as we can get. To get another positive, we add 360 to that, and that gives us 497. To get a negative angle, we start with 137. If we subtract 360, we're going to get a negative number, and that would be negative 223. For our third one, if we start with negative 243, that's not positive, but if I add 360 to that, I'm going to get a positive angle. And that would give me 117 degrees. If I come back and I start with negative 243 and I subtract 360 from that, that's going to give me another negative angle. And for that, I get negative 603. For the last one, I had 565. Now 565 is more than 360. If I add 360, I'm going to get farther away from 0. But if I subtract 360, I get 205. That's a positive angle, which is closer to 0. That's the one that qualifies. If I go from that 205 and I subtract 360, then I'm going to get a negative 155, and that would be my negative angle. To To find the measure of the reference angle, right, I'm going to go back to my drawing. So for my first one, my reference angle is this angle, that is 62 degrees. For my second one, my reference angle is this angle here. So to find that, I'm going to do 180 minus 137, and that's going to give me 43 degrees. For the third one, my reference angle is here, and that's going to be my 243 degrees minus the 180 that took me halfway, and that's going to give me 63 degrees. Remember, whether our angle is positive or negative, our reference angle is always positive. For the last one, my reference angle is going to be right here between my terminal side and the x-axis. I know that I have a coterminal angle of 205. So if I take that 205 and I subtract 180, I'm going to get 25 degrees. That's the measure of my reference angle. The last thing we're going to look at is we want to sketch an angle that's big. We're going to sketch an angle that's 4,893 degrees in standard position, and we want to find the measure of the reference angle. So I know I'm going to want to sketch this in standard position, and I know that if it's 4,893, it's going to go around lots of times, but I don't know exactly how many. Well, if I take my 4,893 and I divide that by 360, I get 13.592. This 13 tells me it goes around 13 complete circles and then an additional portion of a circle. So if I take this 4,893 and I subtract 360 times 13, I'm going to get how much is left over, which is 213 degrees. So what that tells me is that my angle is going to go around 13 times. You don't have to count. But then afterwards, it's going to rotate another 213 degrees. So in standard position, my angle lands in quadrant 3. How big is its reference angle? Well, its reference angle is between the terminal side and the x-axis, that's here, and theta reference will equal, right, its coterminal angle, 213 degrees, minus, right, my 180 degrees, which gives me those positive leftovers, which gives me 33 degrees. Okay, those are the things we need to know. You go back and you practice that.